Now we're ready for module 11. So far, mostly what we've done with the computer using MATLAB is to do calculations, read information into and out of a program. There's really only a handful of things that the computer can do. Doing calculations quickly and accurately is one. Another one's making simple decisions, and then doing things over and over again. And it's those things that we use in programming. Whatever language you're using, it does those basic things. It just does it a little bit differently in the different languages. All other languages basically make decisions, yes and no decisions, true or false, using some sort of what we'll call logical variables. So the next task in MATLAB is to learn logical variables. Logical variable can be either true or false, and we'll build a logical expression to put into a variable using relational operators. So we'll have, if you will, expressions where A equals some logical expression, the answer to which is true or false. And it'll be, is 3 greater than 5, or one of these, and we're using sort of the regular symbols, less than, greater than, less than or equal to, greater than or equal to. Is you question if two things are equal and question if they're not equal. And those are the operators that we'll use in MATLAB. You use relational operators to build logical expressions, which is between two variables or constant, and it has to have either a true or false answer. True, of course, being 1, false being 0. So, for example, here's a little thing I did in MATLAB. If I set A to 5, B to 3, C to 10, and D to 2, and I type A less than B, it's going to look up A and B. Is 5 less than 3? That's false. We'll get a 0. Is A not equal to C? Well, A is, so 5 is 5 equal to 10? Well, we have, is 5 not equal to 10, which would be true, or 1. Here's some others. Is A less than B? Is 5 less than 3? False. Is A equal to C? False. Is A not equal to C? True. And we'll do parentheses first. So is B plus D. Is 5 less than or equal to 5? Yep, that's equal. That's true. Now we can have combinations of relational expressions. And there's 3, those are called your logical operators, and there's 3. There's and, or, not. Now, not is kind of the same as in the other table. 2 relations, the answer to A and B is true only if A and B are both true. If it's or, A or B, then it's true only if one, or if either one of them is true. It's false only if they're both false, and not, of course, is the opposite. A couple of variations. If you're just doing 2 simple numbers, then you can use the double and. If you're doing an array and you want to check it element by element, use the double and. Or there's a function. Same thing with the or. That's called the pipe. Use a double pipe, single pipe, or the not operator. So here's a truth table to illustrate how A and B works. If A and B are both true, A and B is true. If A is true, B is false, A and B are false. If A is false, B is true, A and B is false. If A is false, B is false, A and B is false. In other words, the AND operator is only true if they're both true. Or, if A or B is true, it's true. So, A true, B false, true. A false, B true, true. A false, B false, false. So that one's true unless they're both false. And the not operator just gives you the opposite of whatever A was. Again, those are truth tables. We have to, and since we can have expressions that include arithmetic, we need an order, a precedence to know what to do first. Just like the regular one, from left to right, parentheses first, transpose and powers next, multiply and divide next, addition, subtraction, logical not are next, then your relational operators, then any ands, and then any ors. So some examples here. Let me get my pen going here. A plus B equals C and C less than D. All right, well, we're going to go from the left, do parentheses first. So A plus B would be a 10. Well, actually a 15 with it. And then any relational operators, so do it starting on the left, we'll go, is 15 equal to 20? No, that's false. Is C less than D? Is 20 less than 25? That's true. So we have a false and true, which is false. A not equal to B or C and D? Well, A not equal to B, that's true, so I got a true. B is B bigger than D, C bigger than D, that's false. 20 is not bigger than 25. True or false is false. Now here's two that are similar except for I swapped the and and or. And you can test all of these on MATLAB, right? You can put those in. In fact, I'd recommend that you do that. Is A less than B? Yes, that's true. Is C bigger than D? No, that's false. Is B bigger than D? No, that's false. And it said we do ands first. So true and false is false. False or false is false. Now, if I just swap those two, these are the same. True, true, false, and false. But now I'm going to go do the and first. False and false is false, but true or false is true. So see, order matters very much. And you can change the order with parentheses just like you can with arithmetic. I don't want anything anymore. I'm going to go to the next one. Now here's another one that I did in MATLAB. So A, B, C, D, and then a big long expression. And then I did the display F, and it gave me a 1. So again, let's go to our P and see if we can sort out what it was doing. All right, so is A equal to B? That's false, but not false is true. All right, A equal to B is false, not false. Is C bigger than D? False. Is B bigger than D? It is. All right, 3 is bigger than 2. No, I'm sorry, it was a C. But it's still true. All right, now we do the and first. So false and true is false. Then we do the or, true or false is true, and we got out a 1. So there we go. Now, what we're going to want to do, just to illustrate how to use these, is to use them to plot a piecewise defined function. Remember what that means? Your domain is divided up. Your function depends on what part of the domain that you're on, and that's the way we generally write it. So R is 1 to 5, 1, 2, 3, 4, 5. Okay, we're going to do it with logical variables. So if I set up R to be 1 to 5, then I can do a logical expression, and it'll do it term by term. So for example, if I ask if R is less than or equal to 3, well, it'll do it. Is 1 less than 3? Yes. 2? Yes. 3? Yes, because it's got to equal. 4, false. 5, false. So it'll give me 1, 1, 0, 0. So I can do a whole array. So I can use that to figure out how to plot this. That's what I want to do, is plot this. That code should be up there for you to download. It's called Sample Piecewise FB. And I have it here. So if we look back at the our example that we were doing, if x is bigger than 7, then it's a 1. If x is between 3 and 7, then it's x. If x is bigger than 0 and less than 3, then it's a 2. So remember what happens is, if it's true, then it'll be a 1. And if I want, since the piecewise defined function, let's go back. Whoop, there it was. See, between 0 and 3, I want it to be a 2, so I multiply. If it's 3 to 7, I want it to, and I'll multiply by x. Oh, going the wrong way. So if it's between 0 and 3, I multiply by 2, it's 3 and 7. Again, that's implemented in that code. Here's our code. So what I did was I said, let's input where we want to make the plot from, which is what I want you to do. And then I do a linspace on that, number of points, start and stop. And then what I do is I set up my arrays with all zeros. That's a function that'll create you an array, one row in columns. And so I set up 1, 2, 3, 4. And what I did was I said, so if x is bigger than 7, wherever my x's here, for whatever I said here, so all the ones that are bigger than 7 are going to be 1, the rest are going to be 0. If x is between 3 and 7, then that's going to be a 1, the rest will be zeros, and I'll multiply by x. So the only ones that aren't 0 will be the ones that, once that's true, and then they'll have the value x, whatever I multiply by. Same thing here. When the x is between 0 and 3, the rest of them will be 0. I'll go 2 times for 2 times 1 or 2 times 0. And then if I simply add those up, since there's 0 anywhere that's not true, and where that's false, then I'll just be adding up the parts that are true. Here's a little function. If you want to time how long it takes internally to do something, you've got a little clock called tick and tock. Tick turns the clock on, tock turns it off, and without a semicolon, it prints you the time that elapses the tick. And then I do a plot, and we can see there's where I ran it, 0 to 10, 100 points, and you can see from 0 to 3 is a 2, from 3 to 7. It's not exactly 7 because we divided it up, right? So it's going to be the next one past 7, which is like 0.01. As we divide by 100, but it's linear. And then past 7 would be a 0. Now, what I'm going to want you to do for that, of course, in the quiz, there's going to be some logical expressions for you to evaluate. I'm going to want you for 23 to do a different function. I thought, well, I've got it in the PA23 description, but you can use sample piecewise as the starting point, and then you can change it to do the function that I want you to do to illustrate to me you understand how this is working. All right, so I'll see you in the next video.